What are spatial data types in GIS? Or you can just simply say, what are the geographic layers? What is the data structure in GIS? There's multiple questions which can be answered here. Spatial data is having an information of location, latitude, longitude, in terms of meters or in terms of decimal degrees, and specified location also with the attribute data. Attribute means that this is the road, this is the length, this is the highway, like this. So spatial data are of two types according to the storing technique. How do we store the data? One is the raster data, one is the vector data. I'm not just saying vector and raster spatial data types are there. There are databases, web and multi-temporal also, but the basic one are raster data and vector data. Raster data, they are composed of grid cells. That is, you have a table, for example, C, and you have different cells in the combination of rows and columns, and then every cell has a value. This value, for example, a raster image will have a brightness value, will have a digital number, and that digital number is actually the brightness value. And when for example, say, I'll just give you an example here. Then whole geographic area is divided into group of individual cells, and when these cells have different brightness values and when they are combined on a screen or scene, it represents an image. So whatever the satellites are taking, whatever digital photos you are taking, those are raster data, right? Those are all raster data. And the vectors are point, line and polygon. If there are multiple lines, it becomes multiple points, it becomes a line. When you have multiple lines and they make a closed circuit, that is called a polygon. So for example, in this raster, we have, say, the range is 0 to 255. Let us assume it is 8-bit. 2 to the power 8 is 256. So 0 to 255, if I put value here, say some value, digital value, I'm putting it here, say 198 at some point. Somewhere I'm putting 25. So 25 will be close to 0. 0, let us say 0 is black. 255 is white, so 198 is kind of white. So when we have the combination of this black, white, and we color code it, it will become the colored image or colored raster image. Now here you see we have a vector, that is an area which is called a polygon. So connecting points create a line. A point is xy. When you connect it, it becomes a line, and connecting lines, that will create a closed area, that is called the polygon. So vectors are best used to present generalizations of object or features on the Earth's surface. See, if I show you a map, then you have seen a map with roads, Google Maps. You have various areas like the school or colleges. So you can have trees also shown here. So these are all the combination of different point line polygons. So there are DEMs also, digital elevation model. We'll talk about that later. But let me tell you, vector, raster, databases are also there, spatial data types, the web is also there. There is web services you are using, and the multi-temporal. That is the data, geospatial data or geodata with different time stamps. So there are two components of geographic data. One is the spatial data, one is the attribute data. So whatever geographic data is there, you will have two kind of data here. One is spatial data. So this spatial data is representation of geographic features associated with the real world. Spatial data is just about the location. That is, it has the space location. It tells you when I take this data and put it on the globe or on a map, it should fit on the location it is having the spatial coordinates. Okay, so this is the spatial information which every spatial data with the GIS or the image processing softwares deal. This is the spatial data. Then coming to the attribute data. If there is a road or a house, say, what is the different houses nearby? What is the length and breadth of your house? What is the, say, color of your house? The cost of your house? These are all the attribute data. So as I said, two formats of geographic data or the geospatial data. You have raster data and you have a vector data. This is very important because these raster data are the rectangular array of cells or pixels where you put certain values. For example, it is a DM data, digital elevation model, and it is a raster data. So that will contain the elevation value rather than the digital numbers or the brightness values. Then we have the vector data. We have three feature types: the point or nodes which are having single XY location. Then we have the line or the arcs, and because XY location, when you combine multiple XY location, this is the linear string of XY location. That will be called as a line or an arc. Then we have these lines, just combine these lines to make a closed circuit. That will be areas of the polygon. So if you see here, this is a raster image, this is a vector image, you combine them and that becomes a real world image. What you see in different GIS softwares and Google Maps, etc. So now we have to understand the difference, just understand the difference also. See, first thing is the raster data. The type of spatial data, raster data, is that data that consists of the matrix of cells organized into rows and columns in the form of a table in which each cell represents a specific information or a number or a value. Every grid cell will have certain value. For example, as I just mentioned, that if it is a DM, digital elevation model, it will be elevation data. It is an image that will be having a brightness value. Vector data, this is a type of spatial data used for storing data that has discrete boundaries. See, these points are discrete. XY location, the other point will be somewhere else. So it will have a discrete boundary. So you store that data that have discrete boundaries. It will have certain location in your Cartesian coordinate system or any coordinate system you are choosing for your implementation and representation and display. See, this point line polygon are basic vector data. Okay. The raster data is also continuous because you see the grid structure is there. The vector data is discrete. One data is here, one data is here. That is, one road may be here, one road may be here. One polygon will be here, the other polygon will be here. So it is having a discrete data. The raster data represent data in cells or in grid matrix. We have been talking about that a lot now. But vector data, it represents the data using the sequential points or the vertices. The vertices, and then you combine these vertices, it will become a polygon. You have two vertices, combine it, you will become a line. If you have just one vertex, that is going to be a point. Okay. So the raster data is quite simple data. Vector data, very complex data, very cumbersome to handle, but it gives you a realistic picture. For example, the raster data can be temperature, air pressure, the soil pH value, the elevation data, the flow, the distances. All these are the specific values and the continuous data you can have. This is the raster data. And the administrative boundaries, the linear feature, road, rivers, these are the examples of the vector data.